some work on something that's very close to my heart, which is SAP, an endless source of amusement for those that are interested. He's going to talk about the wonders of the protocol. Is the equivalent of something like Telnet meets gzip that's used between client and server, except I guess Telnet doesn't execute code on the client, does it? Okay, so here's Ian.
Right, hi everyone. Everyone hear me okay? Okay, great. Thanks. As Steve said, I'm going to be speaking about SAP. My talk's called System Application Proxy Pwnage. Just a bit about us. I work for a company called SensePost. We're from South Africa. We do actually have a UK presence, contribute to a whole bunch of research, speak at conferences around the world, and publish a couple of books. Myself, my name's Ian Villiers. I'm an associate at SensePost, and I actually normally get paid to break stuff and be miserable to other people. Anyway, what are we going to talk about? We're going to talk about, firstly, why did I do make the effort of speaking here? We're going to go through a bit of the history, because there are quite a couple of people who've actually done decompression attacks against SAP DIAG protocol in the past. We're going to have a look at some of the fundamentals, and then we're going to get to the interesting stuff where we're going to start looking at potentially new attacks, and then obviously draw conclusions. So why this talk? SAP systems carry business critical data. I mean, frequently you find organizations running SAP. It might not be a core business system, but they'll use it for HR and payroll. And there's nothing nicer on a Friday than getting a shell on a remote host. But the thing to bear in mind is that in the end, our job actually goes about protecting information. You put in a very screenshot of some convoluted tunneling session to get an RDP session on a host, and the technical people are reasonably impressed, but a lot of people look at the report and don't quite get it. If you put a screenshot of the CEO's email, it makes a bit of a difference. There are any numbers of attacks against SAP systems. I mean, you've got a whole bunch of SAP vulnerability scanners, etc., etc., etc. This talk is not dealing with those. This talk is actually going to look at attacks specific to the protocol, because the protocol's been around for years, it's really badly documented, and there seem to be some significant shortcomings in it. But firstly, probably the most fundamental issue there is with SAP currently is it's unencrypted by default. It is compressed. It sort of makes it a little bit more difficult to work out what is going on there. And this isn't really new information. The information, this has been known for a considerable while. So in a nutshell, I think of it as such. We've known for a really long time that plain text protocols are bad, even if they are convoluted in some way. We've also known that security by obscurity actually doesn't work. At some point, people are going to work out what's actually happening. And we know for a very long time that security gets broken once people are able to infer enough information. Okay, a couple of disclaimers. Firstly, SAP is really big. In the word of Rogan Dawes, who works with me, sort of says SAP is a behemoth. It's huge. There's also very little documentation out there. Years ago, when I did ABAP development, I had a service.sap.com account. I don't anymore because I'm no longer a SAP partner or SAP customer. There's absolutely no documentation out there on SAP DIAG protocol, because apparently they do disclose it to business partners, but you need to sign an NDA, I believe. Custom tool sets require development. This stuff I started playing with about 6 months ago. I think I made a lot of progress, but there's still so much I don't know. Additionally, the virtual machine I have with SAP, it's a reasonably outdated SAP installation. It's actually fine for protocol analysis. I've tested this stuff on slightly newer versions, but for what I've got, this actually works fine, and it illustrates it really nicely. But the problem we have is some of the server type attacks that I'll be illustrating might not necessarily work on brand new systems. But as I said, I think where we're going here is relatively new, so I've got no idea. I've tried to cover a lot of ground. As I mentioned, I get paid to break stuff and do assessments, but the problem that we sit with is it's virtually impossible to do a complete job. We're talking about a massive system. And also I've been on project between, so this has become a pet project of mine after hours whenever I have spare time. What I want to see is I want to release the tools as is and the research I've got currently now. I don't really say I want to see some SAP O-Day in the next couple of months, but what I'd like to see is I'd like to see people starting to play with it, and basically so that more details on DIAG actually sort of start making it out into the public domain. Lack of documentation means my analysis is probably not spot on. I haven't even looked at reverse engineering binaries or anything. Pretty much everything has been analyzed from a protocol's perspective. Finally, my machine is going to be a bit of a dog. I was planning on presenting with a secondary machine running my SAP instances. I had some technical issues yesterday. It means I'm running SAP in a VM. So if things seem really, really slow, please just bear with me. Right, let's look at the history of decompressing SAP diag. As I said, it's been around for quite a while. The first paper I could find was actually published by two guys from Securon. It was published in July 2009, and they figured out that it was possible to decompress the protocol by writing a sort of fake SAP server and connecting to it with a SAP GUI client, and this server would actually play the previously captured compressed information back to the GUI, and they were able to extract the decompressed information from the memory using a debugger. Not particularly easy, but reasonably interesting. But there's more than that. Last year, a guy called Denis Yurechev, he discovered that similar compression was actually used in MaxDB, also a SAP product. The nice part about it is MaxDB is actually used to be open source. So there's a ton of information and source code actually out on the internet. And he wrote a utility for decompressing SAP traffic. But the problem was it was also not particularly user-friendly, because it basically required that the user sit with Wireshark, capture all the various bits of pieces of the SAP messages, rebuild the compressed stream, and then run his utility against that. Because obviously the decompression is not going to work until you've got the complete stream. So what it required is you had to identify in Wireshark SAP compressed data. For that, there's always a magic at packet data, offset 17 and 18, 0x1f, 0x9d. That indicates that it's a compressed packet. What he'd do then is he'd have to manually string all of these bits and pieces back on using a hex editor. You'd end up with a complete message, and then we could actually go along and decompress it. So in pictures, if we look at SAP communication between SAP server and the client, we get our first packet which comes in. Sorry, that's not really clear. Can everyone see that? But basically at packet data 0x17, 0x18, we've got that magic, 1F9D. We now know that that is the start of a SAP compressed communication stream. Subsequent packets don't have that magic. So we can carry on building up this message until we've got the complete message, until we've got a whole bunch of packets with a whole bunch of information. And at this point, we've got a compressed SAP message, which means we can take it, we can run it through SAP decompress, and we get compressed information at the top left, and we get the decompressed information, which is showing on the right, bottom right over there. So that's relatively interesting. And the large chunk of what I'm going to be demoing today is actually based on the stuff that Denis actually did. It's really, his work was awesome. So if we look at understanding the fundamentals, we've got a bunch of stuff we've got to try and figure out in the lack of documentation. We've got to try and understand the compression. We've got to try and understand the compressed protocol in order to make it easier to simplify the process of sniffing and decompressing this information. Also, we're decompressing stuff, which means it's theoretically possible to recompress it. Want to have a look at understanding the SAP protocol, what makes SAP GUI tick. And then finally, when we understand all of this, we're in a position where we can start identifying attack vectors for SAP which haven't previously been considered. Compression algorithm is nothing fancy. It's actually a variant of Lempel-Ziv compression. There are two variants actually in use, one called LZC, one is LZH. SAP actually supports both. I've tried it, I've tested it, it supports both of them, which actually indicates, I've got a very strong suspicion, and that's substantiated a little later, but basically that this code base shared between SAP and MaxDB uses the same code base, or at least very similar code, in order to perform this specific stuff. The version of compression used is determined by the compression header. I go into that in a little bit more detail. So, okay, understanding the compressed protocol, let's have a look at it. It's fairly easy to parse. There's no information, so I've invented a couple of terms over here. But basically, it consists out of three parts. You've got what I've called the SAP header, something called the compression header, and then finally compressed data. They look like that. You've got the SAP header, which is the first 12 bytes. You've got 8 bytes, which actually include the magic, which are define various parameters surrounding the compression, and then the rest of the message is actually compressed information. The SAP header is interesting. The first 4 bytes are, at least, because the first 4 bytes give us an indication of how long this complete SAP message is. So in this scenario, the first 4 bytes are 0x138. That means 312 bytes. if we have a look on the right-hand side, it says the length of that compressed packet is 316 bytes. And the reason for that is it's because it's the length of the message minus the first 4 bytes. So the actual compressed data is actually 312 bytes, well, including the compression header. Now, I played around a bit with these bytes over here. It doesn't seem to make a difference. And in the tool set I'll be demonstrating a little later, this stuff is hard-coded. So I don't know what they do, but that's it. The compression header gets a little bit more interesting because it's 8 bytes following the SAP header. The first 4 is quite interesting. It's the length of the decompressed stream, and it's little endian. So in this case, AF01 is actually 0x1AF, means there's a decompressed stream length of 431 bytes, and if I skip ahead and decompress that packet, it actually does work. It's 431 bytes. The next byte actually indicates the version of compression or the variant of compression that's actually going to be used in SAP. The next one is actually always going to be 1F9D. That is the magic which we use to identify these compressed packets. And then we've got the max bits. Now finally, you've got the decompressed stream, which is all the data that we're going to decompress and tamper with a little later. Okay, as an aside, and my thanks to Baron Filardi, one of my colleagues on this, because I've been very busy and I gave him a bit of code to analyze. The bytes, the length of the decompressed stream, the little endian length of that, is actually declared in MaxDB source code as type SAP int, which is actually a signed integer. The thing to bear in mind, firstly, is that this is actually a field which is under control of the user. It's user-controlled. Programmatic type is SAP int. So if I submit a type of FFFF or a length of that, we actually go along and we get some fairly interesting errors. Later testing actually shows that there may be some stability under certain conditions with SAP itself. It seems to fall over. I'll explain that all when we get to some denial of service stuff. But there's an example. I've changed that. I get this nice error back from SAP server, which says internal TSKH error, session terminated. Right, if we look at sniffing SAP traffic, it doesn't lend itself particularly well to Wireshark dissectors because you're talking about fairly large messages. They spread over a whole bunch of packets, so it gets very confusing. I was originally thinking of doing it with Wireshark. Eventually I decided I'd actually go along and use Java and build a tool. It's a custom tool, custom protocol analysis tool. So I'm using a third-party Java native interface, JNI PCAP interface, because this allows us to sniff directly from the network. We can also use standard PCAP filter strings. We can also read standard Wireshark dump files, etc., etc. And then what we've done is we've actually built a custom JNI interface from the MaxDB code. So this will actually give us a whole bunch of functions which we can use to decompress information. And basically it looks like that. I sort of group connections together. It will show me all the parsed and assembled messages. I've got the option of seeing them in compressed form, in decompressed form, and also at analyzing some of the structures which normally appear in SAP. As I mentioned, it uses JPCAP. It's just responsible for reading the packets either by sniffing or from PCAP dump files, filtering and saving information. And then I use Java for parsing packet data, queue management, etc., etc. And then our custom JNI interface for decompression. How it actually works is like so. One of the issues that I have over here is I can't sniff on VMware interfaces on my server, but normally, so I'm going to load a previously saved dump file. That's it. I'd normally go along and select a specific interface, specify a filter string. In my specific case, I'm just going to load a file from that file over there. This I've captured a while ago. And if I go along and have a look at this, it's got a whole bunch of information. So I can go along, this is the first message that comes through. The first message is always an uncompressed message. I get into that a little later. But basically, I can go along and actually see specifically what's going on over here. In the case of this selected message, there's a whole bunch of additional structures called params, RFCQ, verbs, vars. I go into all that in a little bit more detail later on. But I can actually go along and review what's happening on SAP on the network level reasonably easily. Right. So, Okay, so we've actually gone along, we've simplified this process. We've made it a lot easier for people to actually go along and see what's happening on the wire with SAP. But the big question over here is, what about recompression? And the nice part about it is if we go and dig through the MaxDB code, which Dennis picked up, a couple of functions are actually declared in it. The first one is CS-decompress, which is the one we're using to decompress information. But there's also one called CS-compress, which theoretically allows us to recompress this. And this basically gives us an interface into SAP, because we can modify our JNI library to provide both of these interfaces to Java. So we've actually now got a programmatic interface to decompress SAP traffic using udecompress, which is useful for interception and sniffing, and then also for compressing SAP traffic. That's the method called docompress, which is useful for man-in-the-middle attacks and also useful for assessment of SAP GUI applications. As my talk titled is, Systems, Applications, Proxy, Pwnage, we actually now have got a capability of getting into the stream and modding information. It's sort of like web scarab for SAP. Now, if we have a look at the application protocol, basically what makes SAP GUI tick, there's a bunch of stuff over here. Basically, it's multiplex. There's a multiplexer, which means that there's a single connection per user, per location, per host. If I go along and fire up a second session window, it doesn't establish a new connection. It actually runs through the original connection. The initial handshake is always uncompressed. The first packet or the first message from the SAP GUI to the server is always an uncompressed packet, a message which contains a bit of information, and the server response is compressed. The uncompressed component is relatively static. It's going to take information like the terminal name, and it's going to have a whole bunch of flags called support bits, which are going to change according to the capabilities of the SAP GUI client we're actually working. It looks like that. Terminal name highlighted in red. It's fixed length. It truncates the rest of it. Should have been sensepost.com. But and then at the bottom we've got the support bits. These illustrate specific functionality which is available to the SAP GUI. In terms of message types, now bearing in mind that this is based on analysis, there's probably a lot more, I've tried to simplify it as much as possible, but basically currently what I've seen is two types of messages. You've got simple messages and complex messages. The messages structures of both of these actually differ in terms of the direction of communication from the GUI to the server and from the server to the GUI. So your simple messages from GUI to SAP, you've got a header which includes the OK code, character encoding in the GUI version, and then it might have data, which would be dialog input fields and an XML stream which defines the screen metrics. On the wire, it looks like that. We've got the encoding versions, and over here we've actually got dialog input fields, and then finally an XML stream defining the screen metrics. From the SAP server to the GUI, there's a bunch of stuff. There's a header, there's data, and then finally something called TH. The header once again contains encoding. It contains something called a transaction ID, which in many cases I equate it pretty much with a cookie, except it never seems to be checked on the server side. Under specific conditions, it's actually checked on the client. But really, you've also got the system and the host name and the theme in use by the GUI. And then there's a bunch of other information like the SAP program context and the SAP screen number, which is currently running. You'll have the menus and the keyboard accelerators. You'll have a whole bunch of stuff about input dialogues, which are defined like that. I'll go into that in a bit more detail in a minute. And then screen data. This is just arbitrary information that's actually shown on the screen. It ends with a TH block. I call it TH because you see asterisk TH over there. It includes, once again, the system name, transaction, and once again, the transaction ID. If we look at dialogues, all input fields accept strings. It might be a numeric input field. It's possible to put a string in over there. It's not validated on the client side. It gets sent through to the back end and it's validated on the server. SAP will come back and sort of say, sorry, we're expecting a number, or that's an invalid date, or stuff like that. But the interesting part about it is that the lengths of these strings can actually be manipulated, and they're defined by those 3 bytes before the type declaration. So in this specific specific case, that's a username field. It's got a max length of 12. Type is rsys bname, and that's 0C, 0C are all things which actually influence the type. So in terms of that screen, it would normally look like that. We can go along and modify that, and we can actually modify the SAP GUI screen that's actually being displayed in on our system. And as a result, we can actually modify the strings being sent back to server in a similar fashion. The byte is just before the actual string value, so you can actually go along and modify that. Okay, where all the joy comes in terms of SAP is what I've called complex messages. They basically contain a very, very similar structure to simple messages, but they've got a whole bunch of additional stuff. They've got some XML structure called svars, which doesn't really seem to be used, but it looks like that. And then they've got several other additionally compressed streams. So you decompress the message, you get this decompressed information, but there's several compressed areas of this message which are included. There's one called params. If you'll see that's highlighted, you'll spot the magic in which is highlighted in red over there. There's one called RFCQ, same thing. It looks like that. It's also got a magic. There's one called verbs, same thing. And finally one called vars. These are really interesting, and I'm going to go through them all now. The three that are really interesting are params, vars, and verbs, because they all work in conjunction with each other. And they basically define actions to be performed on or by the objects on the GUI or the server. They get submitted both ways. They basically are actually lists of indexed information. They get decompressed, and they actually get parsed by the ABAP runtime to various fixed-length data structures. So decompressed, you've got something like this called params, which contains a whole bunch of handles to result lists and specific GUI controls. You've got something called verbs, which contains, at first sight, some really interesting information. And you've got something called vars, which contains additional stuff. And how it works is that they actually they sort of parsed into shared structured variables by ABAP, and there's a whole bunch of stuff depending on the type. You've got something called S, where it'll go along and set the value of the object. You've got something called G, which gets the value of the object, and then you've got something called C, which means call method of. And this sort of almost makes me think almost of eval. So here's an example of something. Basically, there we go, 8th vars element. We want to call the method of, and we want to call the method shall execute of that specific object with those parameters. So in this case, this is a modified command execution thing. This will actually pop up cmd.exe on the client, depending on a couple of information. Now, according to SAP, I'm not allowed to disclose too much on this sort of stuff, but basically, you can go along and read up on all these structures in ABAP code. As I said, it's passed by ABAP, and go along and refer to the ABAP structures, OLE PA, OLE verbs, SWCB cont, and see where they're used. It's really interesting. It's really fantastic. RFCQ doesn't seem to do much. It seems to provide primarily data which actually gets shown by the GUI. I've only ever seen them in SAP responses. That assumption may be incorrect, as I mentioned, but it will contain meta information and internal table data. Decompressed, it looks similar to that. Right, so basically we've got the fundamentals. We sort of understand how the stuff is fitting together, and the thing over here is to take all of these various issues and identify SAP attack vectors which have not previously been considered. So as far as this goes, we've now got SAP Prox, which is like so, and it goes along and it exists, or it consists of a JNI interface, which is our custom JNI interface. The difference is it's now got a do decompress method and a do compress method, and then we've got a Java component which is responsible for the GUI and the queue management, and et cetera, et cetera. And how it works is like so. Just give me a minute. As I mentioned, my machine is slow. So we'll be able to say intercept requests, intercept responses. We can say start proxy. And if I come along to my proxy over here, or my SAP, and I connect, we'll now actually get quite a nice insight into the stream, what's actually happening. This is the handshake with the terminal message and the support bits. As I mentioned, it's always clear text. Here's the server response. It's decompressed. That's it. Our screen input dialog, our menus, accelerator keys. Let's send it through. And let's test whether the recompression actually works. So there's my plain text username and password. Let's see when we get our error message back over here. Let's just say, oops. Let's modify that. We say send. And if we look at the bottom left, we've now actually got an interface into SAP. The recompression is definitely working. We can intercept the stuff, we can modify it, and we can forward it onto SAP. Right. I just want to close this down, sorry. Okay. Right. In addition to this, we provided it with an attack API, which Villiers, one of my colleagues, actually helped me with. But basically it means that once you've identified potential shortcomings, you can write your own exploits in a scripting language of your choice, provided it's a Java-based one, one which supports Java, like Jython, Groovy, and JRuby. All you have to do is you've just got to dump the jar file into the class path, and it would theoretically work. The scripts exist in a specific location that's specified in the configuration of SAP Prox, and this allows us for canned exploits. So here's an example, Java 1, it's a client-side command execution issue, it's Python. All we're doing is we're calling api.getStringInput, which would be the command we want to execute, and this will actually formulate the process of actually building a response packet and sending it onto the server. My time is a little short, so let's get on here. Right, so we've now got an interface into SAP. We understand a whole bunch of information regarding it. Let's start looking at a couple of new attacks. Okay, so we've got Web Scarab for SAP. Web Scarab does not necessarily make web applications vulnerable to issues. I mean, developers do. But the issue is that we've all of a sudden got a way to really easily get into the stream and start exploiting this stuff. So I think I think it's the first time we actually get such an unprecedented view into SAP GUI applications, and we pretty much know where that left us with all other applications. If you are able to modify stuff which is not being expected, you've got issues. So firstly, let's go along and look at authorization and authentication attacks, and let's do a demo of one. So I'm just firing up sapprox.jar again. And this is all because of the fact that in many cases SAP is going to end up in a position or in a state that it wasn't expecting at a specific time. I'm into intercept requests and responses, and we'll fire up my proxy request here. Okay, what I am going to do now is I'm actually going to load a packet I captured some time ago, which contains a reference to a whole bunch of RFC data. And let's see what actually happens when that goes through. Let's say send. We're going to get a bunch of messages coming through here. That's the client. And we're going to get a nice ABAP dump at some point. We should. Supposed to. There we go, it's coming through now. Okay, so we've actually got an ABAP dump which has actually happened over here. Bearing in mind this is prior to authentication. Right, now SAP at this point is a little bit unstable, so I'm going to go along and punch through a couple of transactions here. In this case I'm trying to invoke the data browser. Okay, nothing seems to happen, let's run it again. Let's send it through. And let's have a look over here, MSC16, let's run it again. And what we're going to get now is something which looks like that. There we go, I think we've just managed to invoke the debugger. this is ABAP, okay? Now, if you have a look here, you'll see that I've actually invoked the debugger, but there's no information being displayed over here. This isn't actually, if we look right at the bottom, it says no authorization for debugging an ABAP program user : it hasn't set the user context for this specific thing. So, I mean, it's literally, we've managed to bypass authentication. We've managed to execute ABAP programs, but it's actually fairly limited, which means there's not actually too much that we can do. However, it gives a perfect illustration of the fact that there are fundamentally broken things in SAP, and it's sort of worth digging. So let me just shut down over here, and then I'm going to go through to my next slide, which actually uses the same thing but starts making things a lot more interesting. Okay. Sorry, I've just messed up my environment here. Okay, right, okay, state management and business logic. Let's have a look at exploiting some of these sort of things. So let's go along here. I just want to move that to my screen next door so that I can see what's actually happening. And let's go on 129. So what I'm going to do now is I'm going to do the same attack, but with a slight difference. So we'll start my proxy, and let's go to SAP, and we'll go along. And what we're going to try and do now, as any pen tester normally will try to do in scenarios like this, is I'm going to try and set the context of the user. Okay, so there it goes. Here my response comes back. It sort of says name or password is incorrect. Let's try and repeat logon. But okay, let's go along and load a compressed packet with RFC information again. And let's see what actually happens over here. And we should get our ABAP dump coming through in a minute. There we go. Let's go along and try and load SE16. Says no, sorry, I can't. We'll run it again. Let's go along and run SE16. And then finally, if we just run SE16 now, we should actually get a dump. But let's see if we can spot the difference. No authorization for debugging ABAP program user is SAP/sys. So we managed to set the user account. So, I mean, this actually indicates that there are some really, it's not exploitable, it isn't, but I mean, basically we're invoking information or applications which we don't potentially, or at least we shouldn't, have access to. Right, not a lot of time left. Let's move to some other stuff. Okay, validation. Validation is basically just passing, there's a bunch of stuff you could potentially do. Do we do it? Do we do it? Yeah, let's do it quickly. I'm going to keep a close eye on the time over here, but let's go along. I want to connect via the proxy, and I'm going to sign on as a user this time. Basically, what this means is that because we can go along and we can modify input going to the back end, SAP doesn't actually cater well for, in various cases where strings are received instead of integers. So you'll actually get ABAP type exceptions. We couldn't cast this to int. It actually will generate the dump. You'll see it. It discloses a ton of information. It becomes really, really interesting. So let's have a look at this. I'm going to fire up the editor, and we will edit one of these parameters when it loads. At some point, sorry, as I said, my machine is quite slow. Let's just go along and make that a update vars, complete message, let's send it on, and we'll see what actually comes back. It should have dumped around about now, so maybe I made a mistake over there, but let's just give it a moment. Being very slow. Okay, while we wait for that to finish compiling whatever in a separate task, let's move on and revisit that in a minute because there isn't a lot of time and I've still got quite a bit to go through. Okay, replay attacks. SAP is exceptionally vulnerable to replay attacks. If you capture information, you can go along and replay them again and again and again. You can capture information, you can replay it again tomorrow. It's actually going to validly process that information. I've got a bunch of SAP packets which aren't actually even recorded for this system. They're recorded for a similar one, which I can still actually go along and replay, and it is actually an application sign-on, and the user would actually authenticate. Nothing hugely serious. I'm not going to bother you with that right now. Where a lot of stuff comes in is actually in terms of client-side attacks, because you've got this huge surface area. So my shouts to Steve for this, because he actually gave me this idea. But if we have a look at this, in many, many cases, and you can understand the business scenarios or the business use cases for this, you actually require the execution of other applications on the client. And it's actually provided for by ABAP. Now, there are a bunch of really old ways of doing it which are actually deprecated and frowned on by SAP. These are two, one called GUI run or WS execute, and they've actually been deprecated and they've been replaced by a different way of executing commands called CL GUI front-end services. The thing is, and this is the fantastic part about it, because we've got so many different versions of SAP servers and SAP clients, there's literally a ton of stuff out there, and they've all got to be sort of compatible with each other. So they have to have backwards compatibility, and so the newer clients still support these old deprecated methods, even though they've got some shortcomings. They do, however, they do provide you with a prompt to sort of say you are now going to execute something. Okay, so basically that's WS GUI run. You'll see the highlighted bottom, it will say execute. It's a simple message. It comes and sort of says execute whatever command we want to. The other P, which is highlighted over there, would be parameters you provide to a specific command. And let's do a demo of this. Okay, there we go. This is my input validation, SAP paging overflow when storing data in the ABAP. I mean, it's just really interesting. So, as I said, I've got nothing exploitable here, but go forth and have fun. It's right. Okay, let's just close this. I want to refresh my client because it kills my machine to some extent. And in this case, what I'm going to do is I'm going to run it on Windows because I've got a nice little client execution utility over here. 13129, and let's intercept requests and intercept responses, and I'll go along and connect to SAP. Okay, this should be my handshake packet. That's it coming through. And what I'm going to do now, it also provides a nice way of demonstrating my scripting API. I'm now going to execute client command exec.py. And this is going to run, and it's going to prompt me for parameters. There we go. What command do I want to execute? System32 calc.exe. I want to execute it without any arguments. And let's bear in mind, the user hasn't even signed on to SAP at this specific point. It's actually modified my packet, execute C Windows calc.exe. Let's send it through and see what happens over here. Oops. So, thanks. Right, final, I've got to mention this. Sorry, how are you doing for time, Steve?
We're all right.
Okay, cool. Okay, great. We might not have a chance for questions, but call me when you see me around here, and I'll happily, or email me or whatever. Okay, client, the new way of doing this actually makes use of CL GUI front-end services, which provides a new way of executing commands, and it actually uses OLE. So when I was describing the vars and the verbs, one of the things that came through there, I illustrated that whole thing with shell execute. That's defined in the SAP COM object. Right, and that's how it would normally be instantiated when I execute calc.exe. If we have a look at it, SAP GUI provides a ton of COM objects. Using COM Radar, just have a look at any up-to-date version of SAP GUI in C program files, SAP frontend, SAP GUI, whatever the directory is. A whole bunch of them actually contain potentially exploitable functionality. The only thing which has stopped people from potentially breaking a whole bunch of SAP systems up to now is because the majority of them are not marked safe for scripting, meaning it's not possible to instantiate them into Internet Explorer. However, we've now got a way, that's just a sample, just some objects in SAP GUI. But anyway, with SAP Proxy, we can potentially instantiate diverse COM objects provided by SAP, all which have got a whole bunch. There's really a lot of interesting stuff. There's read file, write file, etc., etc., etc. All of this stuff sort of starts begging the question, how bad can it potentially be? Okay, finally, I just sort of want to mention DOS. If we consider the fact that the input stream lengths are the compressed message is under the control of myself, I'm sure a whole bunch of people heard of slow LoRa's and stuff like that, but basically we can go along and we can potentially DOS a SAP server relatively easily simply by sending large or packets indicating that there's a large compressed stream on its way, a bit of information just to sort of make sure that SAP doesn't reject the packets as an uncompressed stream, and just send a bunch of these and we can potentially consume resources on the box. So let's run one. So that's sap.loris.jar. And what I'll do is I'll specify I want to go to 192.168.113.129 on port 3200, and I'm just going to start, let's make it 200 strings, starting threads. Give it a while, it doesn't happen immediately, but soonish, I should, if I try and connect to SAP, it's just sort of not going to do anything. Let's try it direct. No, not yet. Let's try it again now. Still working. Sorry, any minute now. For some reason, okay, this might be, okay, I think it actually might have. Okay, demo gods are not being nice with me. Let it finish one more row here. There we go. Connects, disconnects, connects, disconnects. So anyway, you can potentially DOS it quite easily. It's not particularly sexy, but it's fun. Right, and this is just sort of scratching through a bunch of stuff I looked at for the presentation today. There are potentially any number of additional attacks that we can look at. Right, so let's just bring it all together. We've known a couple of things for a while. We've known that plain text communication, even if it is obfuscated to some way, it's a failure. We know that security by obscurity is really, really bad. And the thing is, we've now actually got a tool set with which we can go along and have a look. We've also got a programmatic interface where we can actually start poking at the SAP diag protocol. I'm hoping this in some ways is a game changer, because I think there's really a lot. I think it's target rich. I think there's a lot that one can dig through over there. And I also hope that it gives a better understanding that more information gets published on diag, and that it changes the way we look at ABAP applications. So happy axering. I just have to mention that SAP does provide encryption for client components in the form of secure network communications. Traditionally, these have all been published by third parties. You'd get a library which allowed server-to-server encryption, but never for the client to the server. SAP informed me yesterday that they are apparently releasing an S&C library covered by the NetWeaver license, but that will only be available in October or November this year. So people should just ensure that they use this stuff, because it might make a difference. I can't comment on that. I've never seen S&C on the wire. I don't know how these things are actually implemented, but we'll see. Okay, this tool set is going to be published under GPL. I've been working on it until last night, so I haven't finalized it and pushed it up onto the blog yet. I'll be doing that during the course of the day. So please keep an eye out on our website, sensepost.com/blog. Any questions? We've probably got well, not ready, but okay. Anyway, or just mail me or catch me around here. Right.
Any questions, anyone?
Okay. Thanks very much.